So in this class we are going to discuss about the implementation of DAF-FFT. So problems on DAF-FFT will be discussed. So as we have discussed earlier, DAF-FFT, decimation in frequency. Decimation in frequency, DAF-FFT. So in the decimation in frequency DAF-FFT, here we have x of n. X of n is nothing but it is going to be the input sequence and x of k is the output sequence. So it will be converting the x of n to x of k. So it converts x of n to x of k. So the x of n would be having 8 samples, means the x of k also would be having 8 samples. So the x of n is a time domain sequence, x of k is the frequency domain sequence. And here if you are having x of n in the normal order, so we can call this one as the normal order. X of k would be in the bit reversed order. So here we have 0, 1, 2, 3, 4, 5, 6, 7. So their binary representation. The bit reversal of the input x of n. So 0, 0, 0 means 0, 0, 0. 0, 0, 1 means it is 1, 0, 0. This is called as the bit reversal. And similarly 0, 1, 1 means it is 1, 1, 0. And 1, 0, 0 means it is 0, 0, 1. And 1, 1, 0 means it is 0, 1, 1. So some other cases are nothing but they will be having, in either way it will be the same value. So this is the bit reversed order. So here we don't have any particular order. Say it is after 0 we have 4, then 2, then 6, then 1, then 5, then 3 and then 7. But this order is called as the bit reversed order, because it is when you represent this one in the binary form and reversing the bit binary, you will be getting the actual order of the output sequence. So that is the DAF-FFT. So on the DAF-FFT, first we have the 8-point butterfly structure, then we have 2 4-point, then 4 2-point. So this is the structure of the DAF. Whereas DAT means then it is opposite. Okay, first 2-point, then 4-point, then 8-point structure. And also we have the butterfly structure is followed by the multiplications of Twiddle factor. So after the structure we have the multiplications, whereas in DAT before the structure we have the multiplications. So there is these are all the differences one can observe in the DAT and DAF. So when you are asked any questions like find the differentiate the DAT and DAF, then we need to represent this one. So x of n in the normal order and x of k in the bit reversed order, it is DAF. X of n in the bit reversed order, x of k in the normal order, that is called as the DAT. So the DAT would be discussed at later stage. Okay, so first we can focus on the DAF. Okay, so the DAF, x of n is in the normal order, x of k in the bit reversed order. That we need to understand. Okay. So this is the structure. So we have the 8-point structure, and then we have W8 power 0, W8 power 1, W8 power 2, W8 power 3 has been multiplied, and here we have the G of 0, G of 1, G of 2, G of 3, and which produces A of 0, A of 1, B of 0, B of 1, which finally produces the x of k. Okay. Similarly here also we will be having x h of 0, 1, 2, 3, and which produces C of 0, C of 1, D of 0, D of 1, which finally produces the x of k. Okay. So this structure being discussed in detail in the last 2 classes. So we have spent 2 classes for arriving at the structure. So now we go for the problems using Dif Fft. Determine x of k for the sequence x of n equal to 1, 2, 3, 4, 5, 6, 7, 8 for n equal to 8. Okay. So here we have the same structure Dif Fft. So input x of n in the normal order, x of k in the bit reversed order, and here we have the 8-point structure, and then we have the twiddle factors. What is W8 power 0? W8 power 0 is nothing but it's going to be 1. And W8 power 1 is nothing but it's going to be 1 by root 2 minus j by root 2. And W8 power 2 is nothing but it's going to be minus j. And W8 power 3 is nothing but it's going to be minus 1 by root 2 minus j by root 2. Similarly, here we have W4 power 0. W4 power 0 also it is going to be 1. And W4 power 1 is nothing but it's going to be minus j. Okay, we have to apply all those values, and then finally we will be getting the output. So the input sequence x of n equal to 1, 2, 3, 4, 5, 6, 7, 8. So the first sample is the 0th sample, x of 0. This represents the x of 0. So here we have the x of 0 is nothing but it's going to be 1, and x of 1 is 2, and x of 2 is 3, and x of 3 4, x of 4 5, x of 5 6, x of 6 7, and x of 7 8. So these are the inputs that's been given. Then based on that, then we have to add them or subtract them. So the first 4 values will be added and the next 4 values will be subtracted. So here we have 1 coming along in this line, and that is added with 5. Okay, so the 5 and this 1, say x of 0 is 1 and x of 4 is 5. So both of them will be getting added. So here we will be having 1 plus 5, that is equal to 6, and similarly here x of 1 and x of 5 gets added up. So x of 1 is 2 and x of 5 is 6. So 2 plus 6, it is going to be 8. And similarly here x of 2 and x of 6. X of 2 is 3, x of 6 is 7. So 3 plus 7, it is 10. And similarly x of 3 is 4 and x of 7 is 8. So 4 plus 8 adds up to 12. So the first 4 outputs 6, 8, 10, 12 is been obtained. And then we have x of 0 and x of 4 is multiplied by minus 1. So finally we will be getting x of 0 minus x of 4. So I have obtained the subtracted value. The subtracted value is put above the line. Okay. And within bracket is the multiplied value with the W8 power 0. So when you are having minus 4 with the W8 power 0, W8 power 0 is 1. So this product gives you again minus 4. Similarly here we have x of 1 is 2 and x of 5 is 6. So actually here we are dealing with samples that are 4 points away. So x of 0 with the x of 4, x of 1 with the x of 5, x of 2 with the x of 6 and x of 3 with the x of 7. But here all are contiguous numbers. So continuous numbers. So what happens is that the 1 minus 5 gives minus 4, 2 minus 6 gives minus 4, 3 minus 7 gives minus 4, and 4 minus 8 gives minus 4. So for this problem we get this same value. So what is W8 power 1? W8 power 1 is 1 by root 2 minus j by root 2. 1 by root 2 is 0.707 and minus j into 0.707. So when you are multiplying with this minus 4, then you will be getting minus 2.828 plus j 2.828. And then here we have minus 4, that is multiplied with minus j, minus 4 and minus 4 minus j, you will be getting 4j. Again the minus 4 is multiplied with the W8 power 3. W8 power 3 is minus 1 by root 2 minus j by root 2. So already here one minus is there and here also we have minus. So it becomes positive. So 2.828 plus j 2.828. So this product values, okay, this product value is been given as the input for the next 4-point structure. Okay, so similarly here also we have these values are given as the input for this 4-point structure. So 6 adds with the 10 and then you will be getting 16, and 6 subtracted with the 10, then you will be getting minus 4, and the 8 adds with the 12 and you get 20, and the 8 subtracts 12 and 8 minus 12 you will be getting minus 4, and W4 power 0 is 1, so the product is minus 4, and W4 power 1 is minus j, so finally the product is 4j. And here we have minus 4 and here plus 4j, so minus 4 plus 4j has been obtained, and here we have minus 4 and this 4j is multiplied by minus 1, so we will be getting minus 4 minus 4j, okay, before multiplying with the W4 power 0. So here we have minus 2.828 plus j 2.828, and here 2.828 plus j 2.828. So the minus 2.828 and plus 2.828, the real terms gets cancelled, and here we have only the imaginary term alone. So j 5.656 would be the resultant value, and here we have minus 2.828 plus j 2.828 is been given here, and here 2.88 plus j 2.828 is multiplied by minus 1, so it becomes minus 2.828 minus j 2.828. so here we are having plus j 2.828 and here it becomes minus j 2.828, so they will be getting cancelled, and here we have minus 2.828, and here also this 2.88 after multiplying with the minus 1 it becomes minus 2.828, so finally you will be getting minus 5.656 before multiplying with W4 power 1. So W4 power 1 is minus j. So multiplying with the minus j, then you will be getting 5.656j as the resultant value. So here I have not written anything as bracket because W4 power 0 is 1. So the respective of that, then you will be getting the same value, minus 4 minus j, minus 4j. Okay. So then finally we will be getting the 2-point structures. So 16 and 20 are the inputs. So 16 plus 20 you get 36, and 16 minus 20 you will get minus 4. We can forget this W2 power 0 because W2 power 0 is also 1. Okay. And so 16 plus 20 it is 36, and 16 minus 20 it is minus 4. And here we have minus 4 as one input and 4j as another input. So minus 4 plus 4j and minus 4 minus 4j. So 4j is multiplied by minus 1, so we will be getting minus 4j. So minus 4 minus 4j as next one. Then here we have minus 4 plus 4j and j 5.656 added up. So we will be getting the real component is minus 4. The imaginary component is here it is 4j and here it is 5.656j. So adding you will be getting 9.656j, minus 4 plus 9.656j. So here we are having minus 4 plus 4j as it is, and this j 5.656 is multiplied by minus 1. So it becomes minus 5.656j. When it is added with the 4j, then you will be getting minus 1.656j. So the real term is minus 4, the imaginary term is minus 1.656j. And here we have minus 4 minus 4j, and then here we have 5.656j. So 5.656j minus 4j will be getting 1 plus 1.656j. The real term is minus 4 as it is. So minus 4 plus 1.656j. And here we are having minus 4 minus 4j, and this 5.656j is multiplied by minus 1, so we will be getting minus 4 minus 9.656j. So this is in the bit reversed order, so we cannot consider this one as the sequence, but we need to find which one is the actual sequence. So 0th sample first, so it becomes 36, Okay, so the next sample is x of 1. X of 1 is minus 4 plus j 9.656. Then x of 2 minus 4 plus 4j, and x of 3 minus 4 plus 1.656j. Then x of 4, x of 4 is minus 4, and x of 5 minus 4 minus 1.656j, and then x of 6, that is minus 4 minus 4j, and then finally you will be getting x of 7, that is minus 4 minus 9.656j. So x of n, from the x of n we have deducted the x of k. So when you are doing it with the normal formula method, it will be taking enormous time. So when you calculate this one using this structure, it takes much lesser time. Okay. So here I have also mentioned what is this one. So minus 4 into W8 power 1. So W8 power 1 is 1 by root 2 minus j by root 2, but it is 0.707 minus j 0.707. So multiplying them, then you will be getting minus 2.828 plus j 2.828. So these are all the calculations that we have done for obtaining the values. Okay. So given x of n, we have in DIFFT we have to write them in the normal order. Okay, and after getting the outputs, then we have to find the actual order, because it is in the bitreversed order. So from the bitreversed order, then we have to find the 0th sample. Afterwards, then you will be getting the first sample, then second sample, third, 4, 5, 6 and 7. So these sample values has to be arranged in the proper order, so that you will be getting the output. And one more thing is that we need to apply the twiddle factor values. So the twiddle factor values are nothing but it is W8 power 0. W8 power 0 is e power minus j 2 pi by n power 0. So e power 0, it is going to be 1. So it is always going to be 1. And W8 power 1 is nothing but it's going to be e power minus j 2 pi by n. And actually here we will be getting e power minus j 2 pi by 8. 2 by 8, it is going to be 1 by 4. So e power minus j pi by 4. So it is cos pi by 4 minus j sin pi by 4. Cos pi by 4 is 1 by root 2. The sin pi by 4 is also 1 by root 2. So cos pi by 4 minus j sin pi by 4. So it is 1 by root 2 minus j by root 2. Similarly, W8 power 2, it is nothing but it's going to be e power minus j 2 pi into 2 by 8, or it is going to be 4 pi by 8, or it is going to be pi by 2. Pi by 2 means it is cos pi by 2 is 0, sin pi by 2 is 1. So e power minus j pi by 2 gives you cos pi by 2 minus j sin pi by 2. So finally you will be getting 0 minus j into 1, or it is minus j. Then finally we will be having W8 power 3. W8 power 3 is e power minus j 2 pi by 8 multiplied by 3, or it is going to be e power minus j 6 pi by 8. So e power minus j 6 pi by 8 is e power minus j 3 pi by 4, and so we will be getting the minus 1 by root 2 minus j by root 2. Okay. So 3 pi by 4 is 135 degrees. So 135, here sin 135 is positive, but cos 135 is negative. So finally we will be getting minus 1 by root 2 for cos, and then sin 135 is positive, so it is going to be, but it is having minus j. So minus j into 1 by root 2. So minus 1 by root 2 minus j by root 2, like this will be. So the twiddle factor values must be remembered properly. Similarly, W4 power 0 is also 1. W4 power 1 is e power minus j 2 pi by 4 it is going to be pi by 2. E power minus j 2 pi by 4. Okay. So it is e power minus j pi by 2. So it is minus j. So W4 power 1 and W8 power 2 both are same. Okay. So multiplying the numerator by 2 and the denominator by 2, you will be getting W8 power 2. Okay. Both are one and same. So DAF FFT. The DAF FFT can be calculated in this manner. So next we move on to the DAF IFFT. So DAF IFFT. So IFFT means inverse fast Fourier transform. IFFT is inverse FFT. Inverse means it is going to be from x of k we have to find x of n. Okay. So the input sequence is x of k, output sequence is x of n. So input sequence is x of k. Wherever x of k comes, then it has to be in the bit reversed order. Don't think that the input is normal order, output is bit reversed order. Don't think in this manner. X of k means it is in the bit reversed order. X of n means it is in the normal order. That's all. X of k is bit reversed order. X of n is normal order. So actually it is nothing but it is putting a mirror at the output stage. Mirror here if you are placing a mirror and then replacing the entire structure at the other side, so it is nothing but it is going to be a mirror. So x of k output mirror x of k becomes the input, then followed by that you will be having the multiplications, then you will be having this 4 2-point structure, then again multiplications of twiddle factors. Okay. So here we are having the multiplication W2 power 0. After that only the butterfly structure is arriving. So you need to understand this order. Here also we can say that x of k, then multiplications by the twiddle factor, then 4 2-point structure, then multiplications by the twiddle factor, then 4-point structure, then multiplications by the twiddle factor and 4-point structure. And finally here we will be having 1 by n. Okay, 1 by n is also will be placed. So also we need to note that it is Wn power minus nk. It is not Wn power nk. It is e power plus j 2 pi by nk by n into nk. So we will be getting e power Wn power minus nk. Okay. So it is W4 instead of W4 power 1, you will be having W4 power minus 1, and it is W8 power minus 1, W8 power minus 2, W8 power minus 3. So whenever you have these structure, then if you are having any complex terms, then the conjugate terms has to be replaced. Say consider we have W8 power 1 is 1 by root 2 minus j by root 2. Here W8 power minus 1 is 1 by root 2 plus j by root 2. Okay. 1 by root 2 plus j by root 2, and W8 power minus 2 is plus j, W4 power minus 1 is plus j, W8 power minus 3 is minus 1 by root 2 plus j by root 2. Okay. So applying the problem, so the same output, say x of k is given as 36 minus 4 plus j 9.656j, 36 minus 4 plus 9.656j minus 4 plus 4j minus 4 plus 1.656j minus 4 minus 4 minus 1.656j minus 4 minus 4j minus 4 minus 9.656j. So we got the same output here. Okay. The output that we have obtained in the previous method, we are going to use the same output and we give it as the input for the IFFT, and then we have to get the required output x of n. X of n would be known to you as 1 2 3 4 5 6 7 8. So here we are getting the output. How we are getting? We have to check. Okay. So x of k is in the bit reversed order. So first we have x of 0, then x of 4, then x of 2, x of 6, then x of 1, x of 5, then x of 3 and x of 7. So x of 0 36, x of 1 minus 4 plus j 9.656, and x of 2 minus 4 plus 4j, and x of 3 minus 4 plus 1.656j, and x of 4 is minus 4, and x of 5 is minus 4 minus 1.656j, and x of 6 is minus 4 minus 4j, and x of 7 is minus 4 minus 9.656j. This order has to be clearly written. Okay, so when this one is correct, and if you are drawing the structure properly with all the Twiddle factors being mentioned and the Twiddle factor values is also been mentioned, you can expect half the mark. You don't need to give the answers. The structure is correct, the input is being applied properly, the bit reversed order means bit reversed order, and the output is given in the normal order. For this structure, half the marks would be given. Okay, so that is the key. Okay, so when you are preparing for a the mark allotment, we will be doing in this manner. Okay, so not for the answers, but even for the steps we have allocated. When you are doing these kind of problems, you don't need to derive anything. The derivation part of நீங்க மறந்துடலாம். You don't need to do any explanations. வேர்டிங்ஸில் வந்து சொல்கிறது எதுவுமே தேவையில்லை. ஜஸ்ட் இந்த ஸ்ட்ரக்சர் மட்டும் போட்டுட்டு இதில் அவுட்புட் மட்டும் எடுத்துட்டு ஃபைனலாக யூ ஹாவ் டு மென்ஷன் வாட் இஸ் எக்ஸ் ஆஃப் என், அது மட்டும் போதும். ஓகே, ஸோ இந்த இதில் வந்து இந்த வேல்யூஸ் கொடுத்தாச்சு. ஓகே, நவ் வி ஹாவ் தி multiplications with the w2 power 0. w2 power 0 is 1, so we neglect that. And for the first 2-point structure, we have 36 and minus 4 as the input, so adding them, then you will be getting 36 minus 4, and subtracting them, then you will be getting 36 minus of minus 4, you will be getting 36 plus 4, that is equal to 40. Similarly here, minus 4 plus 4j and minus 4 minus 4j as the inputs. So adding them, the complex terms, the imaginary terms will be getting vanished, and you will be getting minus 8 as the answer. And subtracting them, what happens is that the real terms will be getting vanished, and you will be getting 4j plus 4j, that is equal to 8j. Okay, and then it will be having the multiplications with the w4 power minus 1, and then finally you will be getting the resultant. That will be dealt in the next stage. Okay, then we have the first we complete the 2-point structure, then we go for the 4-point structure. So in the 2-point structure, then we have minus 4 plus j 9.656 and minus 4 minus j 1.656. So adding them, then you will be getting the real term is minus 4 minus 4, so we will be getting minus 8, and here it is plus 9.656j and minus 1.656j. So adding them, then you will be getting plus 8j, minus 8 plus 8j. So subtracting them, what happens is that the minus 4, and here it is minus 4 is multiplied by minus 1, you will be getting plus 4, so the real term would be getting vanished, and here the imaginary term then becomes equal to plus 1.656j. already here we are having 9.656j, adding them, then you will be getting 11.312j. Then finally we have minus 4 plus 1.656j and minus 4 minus 9.656j, adding them, then you will be getting minus 8 minus 8j, and here we have minus 4 plus 1.656j and minus 4 minus 9.656j is multiplied by minus 1, so it becomes 4 plus 9.656j, adding with minus 4 plus 1.656j, the 4 and minus 4 would be getting cancelled, and plus 9.656j would be adding with plus 1.656j, and you will be getting 11.312j. So next we go on to the 4-point structure. Okay, so before that we have the multiplication. So here we have minus 8 into 1, you will be getting minus 8, and 8j with the w4 power minus 1. w4 power 1 is minus j, but w4 power minus 1 is plus j. Okay, because it is e power plus j pi by 2, like that you will be getting, and cos pi by 2 plus j sin pi by 2, sin pi by 2 is 1, so you will be getting j into 1, it's going to be j. So 8j into j, you will be getting 8j square, j square is minus 1, so you will be getting minus 8. So here also we have minus 8, and here also we can have minus 8. Okay, so next next we have the input. So the inputs of the first two is 32 and 40, then we have the next two is minus 8 and minus 8. So 32 added with minus 8, you will be getting 24. 32 minus 28, 32 minus 8, it is 24, and subtracting, then you will be getting 32 minus 8 into minus 1, you will be getting plus 8. So 32 plus 8, it is 40. And similarly here 40 added with minus 8, you will be getting 32, and subtracting, then you will be getting 48. So here you can see that the pattern 24, 32, 40, 48. Okay, this pattern is arriving. Then we have minus 8 plus 8j, and here we are having minus 8j multiplied by w4 power 0. w4 power 0 is 1, so no change. So minus 8 plus 8j and minus 8 minus 8j is been added up. So here it is plus 8j and here it is minus 8j. Subtract, adding, then you will be getting the complex terms would be vanished, only the real term alone would be there. So minus 16. So minus 16 is the input at this point. Okay, and multiplied with the w8 power 0, it becomes minus 16. Okay, so it becomes minus 16 as the input. And here we are having 11.312j, and here also we have 11.312j is multiplied with the j, you have minus 11.312. So minus 11.312, this is real term, this is imaginary term, so adding up, then you will be getting minus 11.312 plus 11.312j. Okay, but 11.312 is nothing but is going to be 8 root 2. Root 2 is 1.414, 2 root 2 it is 2.828, 4 root 2 it is 5.656, and 8 root 2 it is 11.312. So 8 root 2 is 11.312. So taking 8 root 2 outside, then you will be getting j minus 1 as multiplication with 8 root 2. Okay, and here we have w8 power minus 1 is been multiplied with this 1. So w8 power minus 1 is 0.707 plus j 0.707, or it is 1 by root 2. 0.707 is 1 by root 2. So taking outside, then you will be getting 1 by root 2 into j plus 1. So here it is j minus 1, here it is j plus 1. So multiplying them and multiplying 8 root 2 into 1 by root 2, 8 root 2 by 1 by root 2, you will be getting 8. And here it is j minus 1 into j plus 1, it is j square minus 1. J square is already minus 1. So j square minus 1 gives minus 1 minus 1, it is minus 2. So minus 2 into 8, it is minus 16. Okay. So in the previous case also it is minus 16. Now also we are getting minus 16. And then we have minus 8 plus 8j, and minus 8 minus 8j is multiplied by minus 1. So we will be getting 8 plus 8j. So 8 plus 8j is multiplied, added with minus 8 plus 8j. So the real term will be getting vanished, and you will be getting 16j. 16j multiplied by w8 power minus 2, that is plus j, you will be getting minus 16. Straight away we are having minus 16 continuously. So hat trick minus 16. So then we have 11.312j and minus 11.312. So minus 11.312 is multiplied by minus 1, you will be getting plus 11.312. 11.312 plus j 11.312. 11.312 is 8 root 2. 8 root 2 into j plus 1. But what is w8 power minus 3? w8 power minus 3, actually here it is minus 3. Okay. It is minus 3, and here also it is minus 2. Minus 2 on each one. So what happens is that it is W8 power minus 3. W8 power minus 3 is minus 1 point minus 0.707 plus j 0.707. So 0.707 is 1 by root 2. So taking 1 by root 2 outside, then you will be getting j minus 1. So here it is 8 root 2 into j plus 1, and here it is 1 by root 2 into j minus 1. So 8 root 2 into 1 by root 2, you will be getting again 8, and j plus 1 into j minus 1, it is minus 2. So minus 2 into 8, it is going to be minus 16. So here we can see that it is 4 in a row we are having minus 16. Okay. So here these inputs, so 24 is adding with minus 16, you will be getting 8, and after multiplying with 1 by 8, you will be getting 1, and 32 adding with minus 16, you will be getting 16, and after multiplying by 1 by 8, you will be getting 2, and 40 minus 16, it is 24, 24 into 1 by 8, it is 3, 48 minus 16, it is going to be 32, 32 into 1 by 8, it is going to be 4. Similarly here 24, and this minus 16 is multiplied by minus 1, so it becomes plus 16. So 24 plus 16, it is 40, 40 into 1 by 8, it is 5, 32 plus 16, it is going to be 48, 48 into 1 by 8, it is going to be 6, and 40 plus 16, it is going to be 56, 56 into 1 by 8, it is going to be 7, and 48 plus 16, it is going to be 64, 64 into 1 by 8, it is going to be 8. So we have x of n is 1, 2, 3, 4, 5, 6, 7, 8. Okay. So we got the output. We know we started with x of n equal to 1, 2, 3, 4, 5, 6, then found x of k, then found x of n using the inverse process. So using FFT we have got x of k, and using IFFT again we got back the original sequence x of n. Okay. So this is the DIF, FFT and IFFT method. Okay. So in the next class we can discuss further.